Hi, and welcome to Zero to Austrian in 20 Minutes by Middle School MBA. I'm John Foster, and I'll be your guide on this short journey. You can find out more about me and Middle School MBA at middleschoolmba.com. As promised, we're going to start from zero. So we're going all the way back to the day that living creatures first appeared on Earth in search of the secret of human progress. So let's go. Since the day living creatures first appeared on Earth, they all face the same problem: how to use the things around them to secure food, shelter, and protection from predators. All creatures must solve this problem. Let's see how they do it. Mice hunt for seeds, wear a fur coat, and dig burrows underground. Birds build nests high in trees. Bears hibernate through long, cold winters. Each finds the best way to survive. All animals today get by much the way their earliest ancestors did. Today's hawk flies and hunts just as hawks did 10,000 years ago. Humans started much like the animals, always hungry, exposed to the elements, and fearful of predators. But unlike animals, humans managed to rise above their natural condition, to go from a short, uncomfortable, brutal existence to one of security, comfort, and vast opportunities. How did that happen? What is the secret of human progress? The secret dates back to our earliest days. When the first caveman picked up a stick to chase away an animal, he was starting down the path to opulent wealth. Here's how. First, he learned that a rock tied to his stick turned it into a hammer. And that improved his ability to gather food and fend off predators. Then he learned to use his hammer to chip other rocks into spearheads. Here, he was using a tool he had made to make an even better tool. With better tools, our caveman could spend less time hunting and more time improving his tools. This process of making tools, freeing up time, and using the time saved to make even better tools propelled humans further and further out of their natural poverty. As tools became more complex and more numerous, people found it necessary to specialize in making or using certain tools, since no one can be an expert at everything. This specialized use of tools allowed individuals to produce more of a particular item than they needed, so they used their excess to trade with each other. As a result, both parties ended up with more and better stuff. So here at last is the magic formula for human progress: to make more and better tools and to split up the work of making and using those tools. When many people participate in making and using tools and share their work with each other through trade, we call that an economy. So that's the secret. It's tool making that sets humans apart. Making more and better tools necessitated specialization and thus trade. That's how we went from living in caves to having supercomputers in our pockets. In the next segment, we'll go into a little more detail on the nuts and bolts of an economy. Here we go. The economy is this amazing thing people have. Its job is to turn natural resources into the stuff we want. Trees, for instance, can be turned into houses. Dirt into airplanes, mobile phones, or food. In each case, the economy takes natural resources like trees, dirt, and water and turns them into the products we want. Practically everything we have comes out of this box, but few people know what's inside. Let's take a look. The economy is actually a huge web of businesses, all networked together. Each business does a special part of transforming natural resources into products. And each step of this transformation brings natural resources one step closer to being the stuff we want. In a primitive caveman economy, there are very few steps in the production process and very few products produced. Clubs, spears, the occasional bowl, it's a tough life. But as economies grow, they add more steps, use more natural resources, and produce more and better products. By the 1800s, people had candles, cloth, books, houses, and crude machines. In the 1900s, we got electricity, cars, airplanes, telephones, medicine, and computers. And more recently, we've gotten mobile phones and the internet. All of these products are produced step by step, starting from natural resources. For example, one company may dig iron ore out of the ground and sell it to another company, which turns the iron ore into steel and sends the steel to another company that turns it into parts. These parts go to still another company that builds them into cars. In reality, there are many more steps in this chain, but you get the idea. Each business figures out which tools it needs to do its particular work and then hires people who can use those tools. Then they join the web of businesses working to produce the things we all want. So this is the big picture on what the economy does and how it evolves. Now we're going to introduce our 3D animated model, which we call Linky. Linky illustrates the stepwise conversion of natural resources into products. The lines represent goods on the way to becoming finished products, and each rectangle represents a business doing some particular piece of the conversion. Each business does its own particular task, and each has its own particular tools or capital to perform that task. Each also hires specialized workers who know how to use those tools. So in Linky, we see specialized capital along with specialized workers. Note that neither capital nor workers can be arbitrarily shifted around. Both are specialized and specific to their particular job. You wouldn't buy an oven to make ice cream, nor would you hire a barista as a surgeon, or vice versa. So now let's hide everything except the capital to illustrate what we call capital structure. Linky demonstrates exactly what capital structure means. How much capital, of what type, in which location. So what you see on your screen is what we call the capital structure, how we arrange the capital to get the best results. A correct capital structure delivers what consumers want most while using the least possible resources. Getting the capital structure right is the key to a healthy economy and a healthy society. The shapes here represent tools which workers use to transform raw materials into products. They can be computers or offices or factories, or in the case of a masseuse, they might be a massage table. For a landscaper, they might be a truck or a lawnmower. So imagine them as whatever tools a business needs. This even includes intellectual capital and financial capital. Whatever it happens to be, we need the right amount in the right location. That is, the right capital structure. You can't just arbitrarily scatter this stuff around without making a big mess. Just ask Venezuela. So how do we get the right capital structure? We're going to answer that question next. To do so, we'll need to examine some individual businesses. Here we go. Let's pull a single business out of the model and look at it more closely. Here we see Joe Steel. Joe takes iron ore and converts it into steel. Using the specialized capital and workers he's organized for just that purpose. As with every business, raw materials, in this case iron ore, enter the business, and products, in this case steel, exit the business. Both the raws and products have prices, which we've designated here as P1 and P2, and we know that sales minus cost equals profit. Let's do some simple math to look at the sales and costs of Joe's steel. First, Joe's sales. Sales equals price times quantity. So in this case, P2, the price of steel, times the quantity of steel that Joe sells. That's his total sales dollars. We're assuming here that his sales price is $8 per pound and he sold 10 pounds for sales of $80. So we're going to take $80 and put it on the sales line. Now we're going to do exactly the same thing with cost. So for Joe's steel, his cost is equal to P1 times the quantity of raws he has to buy. And here, let's say that he pays $5 a pound and needs 10 pounds. So he has a cost of $50. We'll plug that $50 into our formula and then subtract the cost from the $80 of sales. And we have a profit of $30. So we went through those calculations to be sure that it's clear that profit depends on both P1 and P2. This seems painfully obvious, but it's very frequently overlooked. So let's look at this simple relationship between P1, P2, and profits. First, as P1 increases, costs go up, and therefore profits go down. And of course, as P2 increases, that causes sales to go up and profits also to go up. So again, profit depends on P1 and P2, and we know that profit motivates Joe to invest in his business. So the prices drive profit, and profit drives capital investment. This is so important, I'm going to say it one more time. Prices drive profits, profit drives capital investment, and so we can see that ultimately prices drive capital investment. So this is how a single business like Joe's knows how much capital to invest. The prices on each side of the business determine how much capital goes into that business. Now these prices aren't the only factors, but they're very, very important drivers that we have to understand. So if that's how we determine investment in a single business, what happens if we have two businesses? Here, Kim's ore is supplying the raw materials to Joe's steel. And we know that for Joe, his profits and investment depend on the prices P1 and P2. Similarly, for Kim, her profits depend on P0 and P1. So we can see that Kim and Joe's businesses are linked by P1, the iron ore which moves between them. We can see that if P1 increases, that increases Kim's profits and at the same time decreases Joe's profits. The price of iron ore influences both businesses, but in opposite directions. So we see that Kim and Joe's profits are connected by P1, and therefore Kim and Joe's investments are also connected by P1. Prices coordinate profit and capital, not only for a single business, but also between businesses. And notice that this happens whether or not Joe and Kim ever speak to one another or even know each other. This happens automatically because they have P1 between the two of them. Furthermore, this holds true for the entire economy. All of the prices across the economy coordinate the investments of each business. And all of these prices, depicted here as red peas, have a name. We call this the price structure. The price structure is nothing more than a snapshot of prices all across the economy. Each business is surrounded by prices, which determine its profits, which drives its investment, and ultimately results in the capital structure, like this. There's the capital structure again. And of course, the capital structure isn't instantaneous. It grows over time. Now, there's one other variable we have to discuss. That's the cost of borrowing money, or interest. Interest affects all investment and savings decisions. Market interest rates are discovered in a balancing act between savings, spending, and investment. This balance ensures a capital structure that delivers the goods people want out into the future. But artificial interest rates cause distortions to be built into the capital structure, and that causes problems down the road. What happens is that artificial interest rates fool businesses into bad investments. They invest in the wrong amounts of capital in the wrong locations. These malinvestments will eventually flop. But along the way, malinvestments pull in many workers who would otherwise be working elsewhere. When the malinvestments ultimately do fail and businesses contract, these employees lose their jobs and become unemployed. This abrupt correction of the capital structure is called a recession. Recessions are marked by business failures and rising unemployment. The period leading up to the recession, during which the malinvestment accumulates, is called the boom phase of this boom-bust cycle. We refer to the full boom-bust cycle as the business cycle. And the foregoing explanation is called the Austrian business cycle theory. Congratulations! In understanding all of this, you've now become an Austrian.